8.1, comparing and interpreting rates. A ratio is a comparison of two like quantities. That's important for us. And a ratio is going to be comparing two of the same things in the same unit. So there's two like quantities, and can be written in three different ways. So if I have three things, I can write it with a semicolon. So a ratio that looks like this, comparing A to B. I could write it as a fraction, comparing A over B, or I can write it in word form, A to B. A rate is a comparison of two unlike things, so different things that have different units in it. We need to remember rates and ratios should always be expressed in lowest terms. So that means if you have a fraction and it's not simplified, you need to simplify it until you can no longer divide a greatest common factor out of both of those terms. So let's do an example together. Example 1. Your rate of pay is $60 for every 8 hours of work. What is your rate of pay? So $60 over 8 hours. This is a rate because I'm comparing two different units. I'm comparing dollars to hours, but this is not simplified. So I can divide both of these values by 2, which will give me $30 for every 4 hours he works, which is still not simplified. $15 for every 2 hours of work. So this is not telling me his unit rate, though. This is telling me how much he's going to make in 2 hours. So you don't see wages listed per 2 hours, right? Your wages that you're going to get paid is how much you're going to get paid per hour. So right now, as simplified as I could go right now, this is not a unit rate. This is per 2 hours. So if you look underneath here, a unit rate is a rate in which the denominator is equal to 1. So up here where we stopped at $15 over 2 hours, I want my denominator to be a 1. So I need to divide both of these by 2. Now 15 isn't an even number, but I can still cut it in half. So I will get $7.50 for every 1 hour. And we can always write that. So the unit rate is $7.50 per, that's your slash, per hour. That's how we'll show our rate. Again, we would never say per 2 hours, so simplify it down so that our denominator is equal to 1 for a unit rate. Example 2, a Japanese-made car can travel 50 kilometers on 4 liters of gas, and a Canadian-made car can travel 160 kilometers on 13 liters of gas. Which car gets the better gas mileages in kilometers per hour? So we need to compare those things in terms of 1 liter for both of them, because our Japanese-made car is telling us for 4 liters and our Canadian-made car is telling us for 13 liters, but we need to get that to be per 1 first. So use unit rate to compare always. So for the Japanese-made car, we have 50 kilometers to 4 liters. So we need to divide up these things by 2, 25 kilometers for 2 liters, but I need this to be as a denominator of 1 for my unit rate. 25 divided by 2 is 12.5 kilometers per liter. So that's my unit rate for that one. Now we need to do the same thing to compare which one's better. So the Canadian-made car has 160 kilometers for 13 liters. Now we want to divide both of those by 13 so that my 13 becomes a 1. 160 divided by 13 is 12.5 12.31 kilometers per liter. So here we want more kilometers per liter, right? We don't want the lower number, 12.5 or 12.31. So the Japanese-made car has better gas mileage. This per hour here, this H should have been up per liter in our question. So which car gets the better gas mileage in kilometers per liters? 12.5 versus 12.3. Our Japanese-made car has a better gas mileage. Example 3. Which is the better buy for a turkey? 12 kilograms for $42.89 or $1.49 for 1 pound. So here we have two different units, kilograms and pounds. So we aren't even going to be comparing the same thing. So we need to do that first. Since we already have per 1 pound over there, we should change our 12 kilograms to pounds. And I put a hint here that there's 1 kilogram is 2.2 pounds. So we need to do some math there first. So setting up a proportion, 1 kilogram is 2.2 pounds. 12 kilograms is how many pounds? So just cross multiplication. 12 times 2.2 is 26.4 pounds. So we need that to be per 1 pound. We have $42.89 for 26.4 pounds. We need for how much for 1 pound? So really we're just dividing the two. 42.89 divided by 26.4 is $1.62 per pound. That's for this one. Or is $1.49 per pound better? So you want to pay less here. I want to pay less money for my turkey. So $1.49 is less than $1.62. So our second option would be better. $1.49 per pound is a better buy. I'm paying less money per the same unit, per 1 pound. So rate of change is defined as the ratio of different units. From grade 10, we learned that this can also be represented as the slope of a line, and we used that previously in chapter 62. Your rate of change, your rise over your run, those different things can represent your slope. So for this last example, example 4 says describe a scenario for the graph where we're going to compare the rates shown. So we want to describe like the segment A to B to C to D. Describe some things that are happening using the rates. So we're comparing two things. So I'm going to be comparing distance, so kilometers, over time in minutes is what we're going to be comparing. So for segment A, my rate of change, I start at 0 and I end at 2. So I went up to, my rise was 2 kilometers, over how much time? Started at 0 and I ended at 30 minutes. Now if we want to get that to be a rate per 1 and talk about that, then I need to divide those things. But let's get that into a smaller unit. Say meters. So there's 1,000 meters in a kilometer. So times 1,000. So 2,000 meters took me 30 minutes. Divide by 30. 66.7 meters per minute for segment A. So walk about 30 minutes from home. If we were to describe what could be happening in that line segment, I could say he was at home and he walked 30 minutes and his distance was 66.7 meters per minute. B's line segment, so my rate of change for 2, I changed 0 kilometers. I have 2 and I'm still at 2, so I'm standing still somewhere for about 10 minutes. 0 kilometers over 10 minutes. 0 over anything is 0 miles per minute. So a scenario there, I could stop to talk to a friend, could be buying something, getting a coffee. I'm somewhere that I'm not actually changing my distance for 10 minutes. C, starting at 2 kilometers and I end at 5 kilometers. So I went up 3 kilometers or 3,000 meters. And that took me 40 minutes to 60 minutes, so 20 minutes. So again, just changing that to meters. It'll be 3,000 meters in 20 minutes. So then per minute, divide by 20, will be 150 meters in per minute, in 1 minute. So I went quite a bit farther per minute than I did in segment A in comparison. I went over double, so maybe I was running here because you covered more distance in the same amount of time. So per minute, maybe I was running to catch a bus or running to grab a taxi or something like that. And D, describing what D could be. D, my distance is negative here, so I'm going from 5 down to 0, but my change in kilometers is negative 5 kilometers. This I'm backtracking, and that went from 60 to 65, so in 5 minutes. So changing that, negative 5,000 kilometers in 5 minutes, divide by 5, negative 1,000 meters in 1 minute. So what could happen here? You did catch that cab or you did get on that bus and it took you straight home without any stops. You made a lot farther distance than you would have been walking, still in 1 minute, but you're backtracking back to home. So that would be a question where it's just saying, describe a scenario. I just did that orally for you guys. Just your scenario could be totally different than mine, just as long as it's explaining, well, how am I in comparison to 1 minute? How do I go 66.7 meters in 1 minute, then 0 meters in a minute, to 150 meters per minute, and then negative 1,000 meters per minute? So what could be happening in each of those? Your assignments on page 458, number 1 to 3, 5 to 7, 9, 12, and 13. You've seen lots of this rates before. Just remember that unit rate, if we want to compare some things, you really want to get your denominator to be a 1. It's per 1, per hour, per minute, per day, whatever you're converting it to. Just make sure you have your denominator as a 1.